Last year I want to say we got, actually, if I look back, last year we got to around 113, 116, somewhere in there. There are 129 in the book. Well, there are some lessons in this book that I would skip anyway because they're geometry stuff, and you're going to do it next year anyway, so I would skip them. Like lesson 127, lesson 126, lesson 123, 124. There are several at the end that I would skip. So, no, not all of them, but several of them. So, all right, we're looking at signs of fractions, and then we're going to look at 30, 60, 90 triangles. Yes. We want to add these two fractions. Normally, when we add fractions, we want the same denominator, right? Do we have the same denominator right now? Are they kind of similar?
Yes.
Yeah, they are the opposite. Okay, so we have a negative right here, right? Negative 1/2. Is that the same thing as negative 1 over 2? Is it the same thing as 1 over negative 2? Does that make sense? So, can I take that negative and put it with either the numerator or the denominator? Should I put it with the numerator or the denominator? Why the denominator? Does that make sense? What is our new denominator? X minus 3. Do you see how that works? Now are the denominators the same? So we can say x minus 3 for our denominator, and what would... Yeah, that's an A. Yes, 1 plus 7A. You see how that works? Any questions here? For those, yeah, basically. Okay. Looking at another one. This is the other way they'll ask them. We're adding them together. Are the denominators the same? But they're kind of similar, right? They're opposites, okay? But we don't have a negative in between them, do we? Okay? Is that the same thing as that? Does that make sense? So what can we do? So if we multiply the top by negative 1, what would we get? Y'all with me?
Watch mom.
Oh, because you're multiplying it by 1, basically. Negative 1 over negative 1 is just 1. So you're not changing the value of it. So, yeah, so you can get the same denominator. You can always multiply something by 1. It's like saying you multiply this one by 3 over 3, and that one by 2 over 2. It's the same concept. 2 over 2 is the same thing as 1. Okay. Now you only have to multiply one of them, right? to make that denominator like that. Does that make sense? Any other questions so far? Okay, so what would our denominator become? Any questions on that part? Okay, so can we add them together now? What is our denominator? X minus 3. Does that make sense? When we add these, what do we get? Any questions on those? Do y'all see how that works? Those are the two ways they're going to ask for those questions. Either give you a minus sign and you have to move it, or they'll give you a plus sign and you have to multiply both the top and the bottom by -1. No? Alright. 30, 60, 90 triangles. All of them have their sides set up like this. 1, square root of 3, and 2. These are a special type of right triangle. Normally when you have a right triangle, what do you use to find the side lengths? Pythagorean theorem. But now you're going to be using proportions. This is only true for 30, 60, 90 triangles. Where did the 30, 60, 90 come from? The angles. This angle is 30 degrees, this angle is 60 degrees, and this angle is 90 degrees. Does that make sense? That's where the name comes from. The way I remember it, the square root of 3 is right next to the 30 degrees. Does that make sense? And this should work with Pythagorean theorem. What is 1 squared? What is the square root of 3 squared? And what is 2 squared? Does that work? Does that make sense? The 1 is across from the smallest angle. It is the smallest side. Square root of 3 is 1 point something, 1.7. So it's across from the next smallest angle. The 2 is the largest, and it's across from the largest angle. Does that make sense? Do what? They'll always reduce down to that, yeah. Does that make sense? Because you can multiply everything by 2 or whatever. Does that make sense? Okay, so you want to learn this reference triangle. It's going to be very important to learn it, okay? So we want to find x and y. Can we use Pythagorean theorem on this one?
Well, do you know that that's 30?
No, can we use Pythagorean theorem? Right, okay. You can't do Pythagorean theorem because you are missing 2 different things. Does that make sense? Okay, so what we want to use instead, how do we know that's 30 degrees? 30 plus 60 plus 90. It's the only thing that angle can be. We want to use our 30, 60, 90 reference triangle. Does that make sense? Okay, so I like to draw my reference triangle. Where does the 2 go? The hypotenuse. Where does the 1 go? And where does the square root of 3 go? Right next to the 30 degrees. The 3's go together. Does that make sense? So what proportion could I set up? Okay, 2 over 5 square root of 3 over x 1 over y. Y'all see how that works? Any questions there? Okay, so what do I do to solve for x? And I get any questions on that part? Okay, so what does x equal? You see how that works? If you give me a decimal for this one, I'm going to mark it wrong. You have to leave it as the radical. You can test me on it. It's going to be marked wrong. If you don't believe me, put a decimal. I'm not even going to check to see if it's the right decimal. I'm going to mark it wrong. Anytime you have 30, 69 in triangles, you have to leave it as radical. Okay? Does that make sense? How are we going to solve for y? Use 2 over 5 and 1 over y. So when you multiply, 2y equals 5. So what does y have to equal? If you give me this as a decimal, that'll be okay. 2.5, that's fine. Does that make sense? Yep. Any questions on 30, 60, 90 triangles? Okay, I'm going to draw. See if you can fill in the information. Don't say it out loud. Like, fill in what the side links are. Fill in the side links. What goes here? What goes here? What goes here? Do you notice that the square root of 3 and the 1 aren't always like necessarily on the bottom or on the side? Why not? The 30 degrees is now down here and not up here. Does that make sense? The 2 is always the hypotenuse. Any questions on that one? Okay, let's do one more. You have to learn this, so I want to make sure you understand where they go. What goes here? What goes here? And here? Any questions here? Do you understand how this works? Yeah, it does. You have to learn this. Yes. If you don't learn it, it's going to be a lot more difficult to do the ones with 30, 60, 90 triangles. Any questions on the 30, 60, 90 triangles? Okay.